So therefore, the force of attraction between these two bodies by formula it is F is directly proportional to the product of M1 and M2 and inversely proportional to the what? Square of the distance. So this is the formula. Now, there's something about this formula you have to take note of. This is the proportionality sign. If you change the proportionality sign to equal to, in mathematics, you must what? Introduce a constant. So therefore, F equals to. Now, since we have changed this proportionality sign to equal to, I'll be introducing a constant, which is G M1 M2 over R square. So this is the formula used in calculating the force between two bodies. Now, the G is a constant, as I've said earlier before, and it has a value of G equals to 6.67 times 10 raised per minus 11, and the unit is Newton meter square per kilogram square. So this is the formula of force of attraction between two bodies. Now, we'll be taking some calculations pertaining to this. Okay guys, so let's take this first question. As a case of studies, two spherical objects have masses of 200 kg and 500 kg. So two objects have mass, that is M1 equals to 200 kg and M2 equals to 500 kg. Their centers are separated by a distance of 25 meters. So the distance of separation is 25 meters. Find the gravitational attraction between them. We are asked to look for F, the force of attraction between them. And remember, your G is a constant of 6.67 times 10 raised per minus 11 Newton meter square per kilogram square. Now, by formula, we can solve this using F equals to G M1 M2 over R square. We'll have 6.67 times 10 raised per minus 11 times 200 times 500 all over 25 square. So my force will be now 6.67 times 200 times 500 will be 667,000 times 10 raised per minus 11. Now what's 25 square? It is 625. Now let's divide 667,000 divided by 625, and we'll have 167.2 times 10 raised per minus 11. Now my force becomes, I'll change this to standard form. So I'll take it 1, 2, 3. So it will become 1 point. This is where the point is now. I've moved this point from here to this place to be 1.0672 times 10. How many times did I move? 1, 2, 3. 3. So I'll write the 3 up. Since I'm moving from what? I'm moving positively. I'll write the 3 up. Then times 10 raised per minus 11 is there before. So my F equals to 1.0672 times 10. Now add the power. 3 minus 11 is what? minus 8 Newton. And this is the force of attraction between the two objects of mass 200 kg and 500 kg.
Now, case 2, we have two spherical object masses of 1.5 times 10 raised to power 5 kg and 8.5 times 10 raised to power 2 kg. Their centers are separated by a distance of 2,500 meters. Find the gravitational attraction between them. Now, solving this is also very easy. Now, we have to write all the parameters we are giving out. The first mass is 1.5 times 10 raised to power 5 kg. The second mass is 8.5 times 10 raised to power 2 kg. And you know the gravitational constant is 6.67 times 10 raised to power minus 11 Newton meter square per kilogram square. And we are asked to look for the what? The force of attraction between the two bodies. Now to do this is very simple. By formula, you know force of attraction equals to Gm1 m2 over r square. And don't forget you are given distance, and the distance is 2,500 meters. Now let's impute our what we are given. M1 is 1.5 times 10 raised to power 5 times M2 is 8.5 times 10 raised to power 2 times, don't forget you still have to multiply the gravity too, which is 6.67 times 10 raised to power minus 11 all over distance. The r is 2,500. Now square it, square. So my force equals to, now the first thing to do is to multiply all the numbers together. 1.5 times 8.5 times 6.67. So my answer is now 85.04 times. Now out of the three things you have, pick one thing and add all the powers together. 5 plus 2 plus minus 11 will have minus 4 all over. Now find the square of the distance, which is 2,500. 2,500 square. It's so this is the value. Now what do we do next? Divide 85.04 with the word denominator, which is 6250000. So 85.04 divided by the denominator, and then we have 1.36 times 10 raised to power minus 5. And now on the numerator we have times 10 raised to power minus 4 before. So therefore my force equals to 1.36 times 10. Now add the powers together, minus 5 minus 4. Adding the powers together, minus 5 plus minus 4. You already know plus times minus is minus. That is why I said minus 5 minus 4, which is now minus 9 Newton.
So now we move down to case 3 studies. A planet has two moons of equal mass. That is, moon 1 has mass m and moon 2 has equal mass of mass m. Moon 1 in a circular orbit of radius r. So therefore moon 1 has what? Radius r, and moon 2 in a circular orbit of radius 2r. So moon 2 have radius what? 2r. What is the magnitude of gravitational force exerted by the planet on moon 2? So what we are asked to find is F1 in ratio to what? F2. Now, how do we look for this? Very easy. F1 in ratio to F2 will be, now what's the formula for F1? It is Gm, the mass is the same, mm over, now the distance is r, so it will be r square. Are we together? Divided by, ratio is divided. Ratio means division sign, so divided by, now the formula for the second force will be Gmm over, now the radius for the second force is 2r, so therefore 2r square. You know we always square the radius in the formula of what? Gravitational force. So therefore equals to Gmm over r square, therefore divided by Gmm over, now 2 raised to power 2 is what? 4. R raised to power 2 is what? R square. Now my F1 to F2 equals to, now Gmm over what? R square. Division sign, I can change it to what? Multiplication sign. But when I change it to multiplication sign, this fraction will what? Change upside down. That is, the denominator will come up and the numerator will come down. So it will be Fr square over Gmm. Now we know the mass of moon 1 is same thing with the mass of moon 2, and this G is constant. So therefore we can cancel this out, and then we can cancel this R2 out. So therefore we are left with 4 over 1. So therefore the gravitational force exerted by the planet on the moon is to what? 4:1. So I can write it as 4 over 1, or I can write it like this: F to ratio F1 to ratio F equals to 4 to ratio 1. So you can either write it like this or write it like this. So just now 4 to ratio 1 is our answer.